All right, welcome back. So this is another ALEKS topic. It's called understanding the difference between strong and weak acids. And this is a little bit of a confusing problem, so I just wanted to run through it really quickly. So basically what it's asking is if you make a dilute solution of this acid, what actual species would be present in that solution? So, like if we had a beaker, and into that beaker we had some water, and we put in this HClO2. What would actually be present in this solution? Would it completely dissociate? Would there be ions? Basically, what would be in there? So the whole idea with a weak acid is if I want to write out a chemical reaction of what's going to occur when I put this into water, so this would just indicate that I'm putting it into water. We're going to get a little bit of dissociation. Sort of the unique thing or the cool thing about a weak acid is that this dissociation into H plus and ClO2 minus, it's going to happen a little bit, but it's also not going to happen a lot of bit, right? So most of the time, it's actually going to stay, if we're talking about a weak acid, it's going to stay in this sort of molecular form where it has not dissociated at all. So if you were like a little scuba diver and you went in to look at what sort of fish are in this solution, the fish that you're going to see most often would be this HClO2 fish, right? It would be this whole thing intact in the solution. Now every once in a while you'd see this very exotic H plus or ClO2 minus, but most of the time it's going to be that HClO2. So you would see a little bit of the H plus and a little bit of the ClO2 minus, but mostly it's just going to be this HClO2. So for this problem, if we're told that this is a weak acid, the first thing we're going to write is just the same HClO2. If it's a weak acid, that means that most of it's actually going to stay intact, but some of it's going to turn into H plus, and some of it's going to turn into ClO2 minus, but most of it's going to be HClO2. So this would be what I would write down for this problem. If it's a weak acid, we're going to write the same compound again, and then we're going to add in H plus, and then whatever the remainder of our species would be. So the ClO2 minus, right? That's just sort of what would be left over after you take away the H plus. So for H2S, same thing. The first thing I'm going to write is just H2S. If it tells me it's a weak acid, then that's going to be the first thing that I write. The next thing I'm going to write is H plus, because if it's a weak acid, then that indicates some of the H plus would be coming off. So we could write H2S is going to be in equilibrium with H plus, and then plus whatever's left over. So if you've got H2S and you take off H plus, then that means that HS minus must be sort of what's left over, right? The other bit. So that would be my other species that I'd plug in here. H2CO3, same thing. First thing I'm going to write, first and foremost, is just that same, weak acid species, H2CO3. Next, H plus. Next, whatever's left over, HCO3 minus. So, the difference between H2CO3 and H plus is HCO3 minus. So those would be my species there for my weak acids. So all of your weak acids will follow this sort of general motif, but your strong acids are going to be a little bit different. So your strong acids, you're just going to write H plus and I minus. There's not going to be any HI remaining in your solution, because when you put HI or any other strong acid into water, it's going to completely dissociate, right? That's sort of the unique thing, or the cool thing about a strong acid, is this is going to completely dissociate in H plus and I minus. You're not going to see any HI. This would be an extinct fish, right? It's not going to be in your solution at all. This HI is going to completely dissociate into H plus and I minus. So all of this is going to be H plus and I minus. You're not going to see anything else. So we're just going to write H plus and I minus for our strong acid, our strong HI, and that's it. I think you can put in water for all of these. It's not necessary. When I was doing this, I just left it off and it was totally fine. Okay, hope that helps.